So the binomial theorem, that's what this is all about. And so there it is in all its glory. 1 plus x to the power of n, and we've now seen that we can write that using the binomial coefficients, nc0 plus nc1x plus nc2x squared, and so on and so on and so on. And somewhere in the middle would be the general term nckx to the power of k. I could write that in a shorthand notation by making use of the capital sigma, which you may recall from stats means sum. And so I just put the general term there, nckx to the k, and we're saying, well, we want all the terms starting from when k is equal to 0, that would be nc0, all the way up to when k is equal to n, and we'd get ncn x to the n. So it saves writing out all the terms. And nck, we found out, was exactly the same as combinations. And formally, that's n factorial over k factorial, n minus k factorial. The other thing to note, in any expansion, there'll always be n plus 1 terms, because the first term is 0. And we're going from 0 to n, so we'll always end up with n plus 1 terms when we expand out. Now, 1 plus x, very limited, so we can expand our binomial theorem to be a plus b to the power of n. The only difference there is we then have to worry about a and b and the powers. So it'll be b to the power of k, so b is replacing the x if you like. But now it's not 1 to the power, because of course 1 to the power in the original one we didn't write down because 1 to the power of anything is 1. But now we'll have a to the power, but recall that the two powers must always add up to give n. So therefore the power of a must be n minus k in our general form. Alright, 11C4 evaluate without your calculators. So that would rely on us knowing the definition. We get 11 factorial on 4 factorial, 7 factorial. But remember the idea of rolling out the factorial. So we've got some cancelling here. The 7 factorial will go into the 11 factorial, so will the 4 factorial. But I'm going to choose the bigger one. So 7 factorial leaves me with 11 times 10 times 9 times 8 over 4 times 3 times 2 times 1. And then we can have some fun cancelling. What have we got? 4 2s are 8. And then 3 will go into 9 3 times. 11 times 10 times 3. 330 is what we end up with there. Find the value of n. So NC5 is the same as NC8. Well, that makes use of that identity we saw, which says Pascal's triangle is symmetric. So NCK will be the same as NCn minus k. Or another way of thinking about that is the two numbers down the bottom should add to give the n on top. So I know that 8 must be n minus 5, so n would be 13. 8 and 5 are 13. Then that would work. 13C5 would be the same as 13C8. If you think about the definition of the C, that makes sense because 13C5 would be 13 factorial on 5 factorial. Two numbers have got to add together to give n, so it'd be times 8 factorial, whereas the 13C8 would be 13 factorial on 8 factorial. Two numbers have got to add to give 13. 5 factorial, so you get exactly the same thing. Now, NC7 plus NC8 is 20C8. So that one's using that relationship in Pascal's triangle, which is saying, oh, well, to get any number, we would add the two numbers above it. So 20C8 would be on the 20th row there. So it must have come from the row above. So n would be 19 in this case. So 19C7 plus 19C8. Now, of course, if you didn't spot those, again, you could go back to the factorial notation and solve the resulting equation. Now, a bit of work there, but it would work. Find the fifth term in the expansion. Well, I'm not going to expand the whole thing out. I'm going to say, well, the general term. Now, I call the general term k plus 1. Because remember, the first term is when it was NC0. And it seems silly saying the naughth term, so I go k plus 1. But anyway, it would be 11ck, the minus 3 on b would be to the power of k, so the 5a would be to the power of 11 minus k. Got to add together to give 11 in this case. Now, I'm interested in the fifth term. So the fifth term would be when k is equal to 4. So we get 11c4, 5a to the power of 7, negative 3 on b to the power of 4, tidies up to b. Well, that's an unsimplified version. So 11c4, 5 to the power of 7, 3 to the power of 4, a to the power of 7 over b to the power of 4. If I was to actually work it out, well, 11c4 is 330, 5 to the power of 7 is 78,125, 3 to the power of 4, 81. Multiply that all together and you get that really big number. Obtain the one that's independent of x. So when we expand it out, somewhere in there, there'll be a term which doesn't have x in it. Which one is it, is the question. So again, rather than expanding the whole thing out, let's play with the general term. Now, I can tidy that up because I've got x squared to the power of 9 minus k, but I've also got the x on the bottom of the fraction, so x to the negative 1, to the power of k, and really, that's what I need to work with, because if it's independent of x, so there's no x there, the power of x must be 0, because x to the power of 0 would be 1. So I want to see when x squared to the power of 9 minus k times x to the negative 1 to the power of k is x to the power of 0. So playing with those index laws, we'll get 18 minus 3k has to be 0, so k is equal to 6. Now we know what k is, I can substitute it back into the general term and work out what the actual answer is. So it'll be term 7, 9c6, 3 cubed over 2 to the power of 6. That would be the unsimplified answer. We want to find the ratio of the coefficients of x to the power of 7 and x to the power of 5. Again, I don't want to expand the whole thing out, so let's get our general term. And so that's 15ck, 2x to the power of k. We're interested in the coefficient of x to the power of 7, which would be 15ck, 2 to the power of 7, and the coefficient of x to the power of 5, which would be 15c5, 2 to the power of 5. That's what we need to simplify. Okay, going back to our definition of factorials. 15 factorial and 7 factorial, 8 factorial. Invert and multiply, 15 factorial, 5 factorial, 10 factorial. And then the 2 to the power of 7 and the 2 to the power of 5 will cancel to give me 2 squared, which is 4. Now we just need some cancelling with our factorials. I guess the easiest one to do is 15 factorial will cancel with the 15 factorial. That'll just leave us with. So now what do we got? The 8 factorial will go into the 10 factorial, leaving us with 10 times 9. The 5 factorial will go into the 7 factorial, leaving us with, good, now you're getting the idea. Okay, so we had 10 times 9 times 4 on 7 times 6. All right, let's play. What can cancel there? 7's a prime number. 6 goes into 9, but then that will leave me with a 2 on the bottom, which will go into the 4. Yeah. And we get 60 on 7. You're going to do this in 2 bits. So 15c and 15e